Welcome to my class on exponential and logarithm function. So in this case, you can see this is 10 to the power x, 2 to the power x, e to the power x. These are called the exponential function. And if you write something or some function or the number in terms of log, that is called the logarithm function. Now we can see what is logarithm function. So in order to define logarithm, I am taking one example as 2 cube equals to 8. So if you calculate 2 to the power 3, the answer is going to be 8. Now this sort of thing we shall write in terms of logarithm. In fact, we will define what is logarithm. So in this case, if you can have look at it, this language I have written here, 3 is defined as logarithm of 8 to base 2 and is written as 3 equals to log of number 8 to base 2. Now in the beginning we have to make habit of writing the logarithm, writing the equation in logarithm form using the exponential form of the equation. So here in this case, first of all, for 2 times or 3 times, if you practice to repeat this language for 3 or 4 times at the same time, if you write from exponential to logarithm functions, that will make habituated to write how the exponential function is expressed in terms of logarithm functions. So let me do, for example, here. So as I am reading here, I will pay attention to this equation also. So in this case, 3 is defined as, so I wrote here 3. 3 is defined as logarithm, so I wrote log. So short form of logarithm is log of 8. That means the number is 8 here to base 2. So in this way, while reading, if you keep on writing the thing, you will become habituated of writing the logarithm converted out from the exponential function. So here you can see 2q equals to 8 is true mathematically, and then if you are writing this thing in the logarithm form, then it is 3. This is the log. This is the number 3, whose log that can be expressed as log of 8 to base 2. All right, and you can generalize this sort of expression of logarithm in terms of a function. So here I use the constant, but here I am using in terms of function in general. So here you can see ax equal to b is an exponential function. So ax plus b is an exponential function, and if I convert that into the logarithm, I will again use this definition. Then I will read like this. Here x is logarithm of b to base a. So while reading, I will write that sort of thing also. So x is logarithm of number b to base a. So we have to do in the beginning only. Later on, we will become habituated of all it. And now in question number in 2, I am marking here. Here I put this constant to the left, and then this sort of constant has variable power to the right. So in order to understand this, don't be stuck to the one side. Okay, you have to understand through both the sides, like from left to right and right to left. So in this case, we used left to right. Now here I will use right to left. So here the same thing will apply. So we can say here that z is log of c to base d. So z is log of c to base d. So in this way, you should practice to express the logarithm from either side. Okay, now I am taking one very special function like y equals to 10 to the power x. This is very popular function that we use frequently in our problem area, especially in the management science and economics, and sometimes in the physical science as well. Now you can see this y equal to 10x. So this is y equal to 10x. This is also in the exponential form. If you convert that, you will have x equals to log of y to base 10, just like in here. And I call this equation 1, another is equation 2. Now what I am interested in at this point that I'm writing both the functions in terms of y equal to x. So in this case, in equation 2, if I interchange x and y together, then it's going to be y equals to log 10x, and I name this as equation 3. Now let's see what is the graph of these functions, and we plot them on the same sheet of graph in order to compare that how both the functions are related to each other. So you can see from the graph, graph is that little bit you can discuss about how we have drawn this graph. And here, like if you put 10 to the power 0 for this graph, so 0, if you put 10 to the power 0, that is going to be 1. So this it will pass through 0, 1. Now if you increase the value of x from 1 onward along the positive direction, in that case you can put value of x as 1, 2, 3, 4, 19, 13, 14, all positive whole number or any number in positive sense, and then you will see that your value will increase like this. And if you put the value of x as less than -1, if you use calculator, you will see that value is decreasing and goes near and near to the x-axis, and but it never touches the x-axis. That means this curve shows asymptotic nature about the x-axis. Similar thing you can do for another function which is in logarithm form. So in that case, if you put x equal to 1, you take a calculator and then you enter log base 10 and you put 1 for x. In that case, you will see that this value is going to be 0, so this curve will pass through 1. Now if you in the calculator, if you again try the value more than 1, you will see that the curve is slowly rising this way. And if you put the value of x greater than 0, this is not the 0, 1, it should be 1, 0. Okay. And now if you put the value of x less than 1 until 0, before 0, in that case you will see that your curve is descending down and reaching near and near to the y-axis, and it seems like as if it goes near and near to y-axis but never touches that axis. That means the curve of log x has the asymptotic nature about the line x equals to 0, which is called y-axis. Alright. Now let's see the reference of this line. That is going to be y equal to x. So y equal to x is a line. If you compare these two curves, you can see that one curve is reflected image of another curve and vice versa. In that case, what you can say that the function y equal to 10x and the function y equal to log x to base 10, they are inverse functions to each other. So this is the important property of exponential function and its logarithm function. What happens? Then you have to note that when you plot the graph together, you will see that one function is inverse to each other. Okay. Now I will discuss about some examples related to the thing that we have done just now, and I will give one example here. One example is that you can say convert. So here in this case, you can see this equation is given in terms of exponential form, and that exponential form we have to convert into the logarithm form. So just now we have seen that how to express this. So 2 is the logarithm of number 100 to the base 10. In this way you can express 10 square equal to 100 to the logarithm form. Let me give you another example. So here in this case, we have converted exponential function to logarithm form. Now we'll do the reverse work. Here we are going to convert log to the exponential form. So in order to convert this log to the exponential form, so you can write something like this, like y equals to log of 10,000, log of 10,000 and to base 10, and if you convert back to the exponential form, it is going to be 10 raised to the power y is equals to 10,000. And fortunately in this case, you can also be able to calculate the value of log 10,000 to base 10 without using the calculator. So in that case, what we have actually 10 to the power y is going to be equals to, this is 10 to the power whole, and the bases are the same. So in that case, therefore you can write y equals to 4, that is your log value of 10,000 to base 10 is going to be equals to 4. Let's see few more examples so that it will be clear that how we deal with the logarithm functions. Okay, now I will take one example, another example, like solve. So in that case, in order to solve it, here you first write the question, and when you write the question, so just use the idea that how to convert this exponential function into the logarithm function. So here you can write x is the logarithm of 0.48, this is 8, and to base 10. So in this case, I suggest you to use calculator, and in the calculator you can clearly see there is a log button and the base is 10 and the given number is going to be 0.48, and if you put equal, that value is going to be this value is going to be 0.319 up to 3 significant figure. Okay, so while dealing with such kind of examples, you should also be able to analyze the type of logarithm that is going to be deal with the number less than 1 or greater than 1. So in your calculator yourself, you can check that if this number is less than 1, you will see that this is always negative number. So in calculator I saw this is negative 0.319 up to 3 significant figure. What if instead of 0.48, if that would be log of 48 to base 10, and here 48 is greater than 1, and here you can see greater than 1, and 0.48 is less than 1. So in your calculator, if you put log 48 to base 10, you will get the answer as positive n. And here you have already seen that if the number is less than 1, and if you calculate this sort of log value for 0.48, because 0.48 is less than 1, then your answer will always be negative. So that sort of thing you should note down while working with logarithm, at least during your practice mode. So in that case, we have got with this. Now I'll discuss about another example also. So let me clear it off first of all. So another example I'm going to write is log base 10 for 10 root 10. Now in this case, you can see that you can suppose that y is going to be equals to log base 10, and here it is 10 root 10. Better if you rewrite this equation. So y equals to log base 10 and 10 to the power half. There is 10 to the power 1 and another power is half, 1 by 2. So it is going to be 10 to the power 3 by 2. So here it is 10 to the power 3 by 2. Alright. So 1 plus half is 3 by 2. Now this is in the logarithm form. Now you convert that into the exponential form in order to find the value of this logarithm, or in order to evaluate this logarithm. So here, if you use the concept that how logarithm can be converted to the exponential form, so in that case, if you use that concept, your exponential form is going to be 10 raised to the power y, and here it will be 10 to the power 3 by 2. Once again, let's see here. If you go from this term to previous term, so you can again read out 10 to the power y is going to be equals to 10 to the power 3 by 2. So in this case, you can see y is logarithm of this number. You can see it here, and to base 10. So if you go in the reverse way from this exponential to converting to the logarithm form, we can again do so. And suppose this is a single number, for example, then this is the here it is called y is logarithm of 10 to the power 3 by 2 to base 10. Alright. Now, what feature you can see here? Base in the left side and to the right side both are the same, so they are the equal number. Therefore, your y is going to be equals to 3 by 2. That is, we are supposed y as log base 10 for 10 root 3, and your answer is now 3 by 2. You can write in decimal form also, that is going to be 1 by 5. So in this way, without using calculator, we can also calculate the value of logarithm, or we can say that you can evaluate the log value. I have one more example for you. So another example I will take as solve. In this case, solve. So in order to solve it, we have used the logarithm term twice in this equation. So there is no need to worry about. You see, you suppose the first glance that log 2 is here, and inside this bracket you suppose that is as if another variable or number. So in that case, if you use the definition of, if you use the idea that how to convert the function from log to exponential form, you will see that log 3x is going to be 2 to the power 1. So it will go here to the right, and this power negative 1 will rise to this base. So one work is almost done now, and this can be also equals to, if you like, you can write 1 by 2, as this is the reciprocal of 2. 2 to the power minus 1 is reciprocal of 2. Now you again use the concept that to convert logarithm into the exponential form. So if you do the same work again, what is going to happen here? Just like here, like x will be here and 3 will go to the right side where this power goes on, rise to 3. So this is the answer. In this way, we can solve the equation which are given in terms of logarithm. I have a few more things to discuss here now. It's very important to understand and know this sort of thing, because that's going to be frequently used throughout your problem solving area. In that case, I'll take one another example, and it says that evaluate 0 equals to, that means what is going to be the value of log 0 for given base 3, and at this time I will say that not only 3, for any base. So here, as usual, you can suppose after that that should be going like this, 3 to the power y. So we are now going to relate 3y to the 0, that how we can get the value of y in this case. Y means we have log base 3 for 0. So at this point, we are going to express this 0 in terms of 3. So if I'm writing 3 to the power negative infinity, then let's see what happens. So here 1 by 3 to the power infinity, and this is going to be 1 by infinity since 3 is greater than 1, and therefore for rising power of 3 will make it bigger and bigger, and the power is, if the power is infinitely large, it tends to infinity. So now therefore it is after this term 1 divided by infinity in place of 3 to the power infinity, and you know that any number divided by infinity is 0. So in another step, for 0 we can write 3 to the power negative infinity equals to 3 to the power y. But you can see that why I have chosen only 3 here, because the right side is 3 and we have to express to the left, we have to express this 0 in the left side in terms of 3 itself. That would be 13. I will take the number 13. But one thing, at this time I am working for the number which is greater than 1. So in this case you can see 3 itself is greater than 1. And if you compare these two sides, because these two numbers are the same, they are equal, so therefore in this case what you'll get, therefore negative infinity is going to be y. That is, y means log base 3 0 is going to be equals to negative infinity, and it is in fact undefined. Okay, so you can check it in calculator also. If you take for any base log of 0, then your calculators will show that this is syntax error. Syntax error means that cannot be defined. So at this time I talk about the log of 0 to the base which is greater than 1. Now I will take the base which is less than 1. So in that case, instead of taking 3, so I have already ready here. So it is now 0.3 and it is now 0.3 over here. So you can take it as another example where I am working for the number. This is 0.3 is less than 1. Before it was greater than 1. Then see what happens in this case. If you again use the idea that how to convert logarithm to the exponential form, we can again write here the next step will be 0.3 to the power y. Alright, so let's work here for 0.0. So if I'm taking 0.3 to the power infinity, what it is going to be? Because you can see 0.3. If you use your calculator, for example, you are finding like 0.3 squared, for example, it will be 0.3309, so that will be 0.09. And if you put cube, that is going to be 0.339327. So this is going to be 0.027. Compare these two values, you can see that as the power is increasing, the result is in the decreasing order, and when the value of this power is infinitely large, for example, this is infinity, then it will tend to 0. So therefore, in place of 0, you can write 0.3 to the power infinity. So therefore, in this case, you can write 0.3 to the power infinity equals to 0.3 to the power y. And if you compare to the both sides, you can say, so therefore you can say y equal to infinity, and therefore your y is now log of 0 to base 0.3, and its answer is infinity. Infinity means that is again undefined. So in your calculator, you can try the logarithm of 0 for any base which is less than 1, and you will see that your calculator will show the syntax error. That means this sort of thing cannot be this sort of thing is undefined. You can see for now another example where you are going to find log for any base. I will say 13 for example, and 1 equals to what? So 0 and 1 are very important number. Okay, so why it is very important number? Because every time or most of the time I will say that we are going to use this 0 and 1 frequently throughout your problem solving area. In that case, let's see how to evaluate this. Now we have got another example also, that how to find logarithm of 1 for any base 13. It can be 1300 also, it can be any number. So at this time, for example, I am taking the base as 13. You can take any other number also. And throughout your problem solving area, you will encounter that 0 and 1 are very significant numbers which you are going to use throughout. So therefore, this is important to understand what is the value of log 0 and what is the value of log 1 for any base. So in this case, I will adopt the same process. I will say let log of 1 to the base 13 equals to y. If you like, you can say ABCD, X, Y, Z, and you can say. And after that, if you convert that to the exponential form, it's going to be 1 equals to 13 to the power y. And here in place of 13 to the power 0 is equals to 13 to the power y. Since any number to the power 0 is 1, so conversely you can write for 1 equal to x to the power 0, or for x to the power 0 you can write that is 1 as you need. Now you compare both sides. This is 13 and this is also 13. So therefore you will have y equals to 0. That is, y means it is log of 13, log of 1 to base 13 is going to be 0. Now into calculator, can you try on checking log of base e 1, log of base 300 1, log to base 10 of 1. Every time in your calculator you will see that if you put log value for 1 to any base like e, 300, 10, alpha, beta, gamma, whatever, in every case your answer will be 0. That means you should note that when you are going to find log of 1, your answer is going to be 0. And move forward to the further explanation of logarithmic terms. And let me check. Now we shall talk further about logarithm, and that is called natural logarithm. This natural logarithm is also called Napierian logarithm. Napierian was the name of the scientist. We had worked a lot on the logarithm, and where it is for the specific base 3, and hence this is also called the Napierian logarithm. And in the natural logarithm, what happens? In other logarithm, the base number you can choose is anything, but here in this case we always choose the base e, and that is written like this: base e if you write, and then the base e, and this sort of log is written as ln. So whenever you see there is written ln, ln means always that is the log to base e, and this is called the natural logarithm, and it is very popular in our scientific area. So in that case, let me tell you something more about that. For example, if something is written like this, ln of 13 means you are going to calculate log for 13 to base e, and note that e is an irrational number. This is not the rational number. This is an irrational number, and its value lies between 3 and 2. And if you would like to check the value of E approximately, it is found that this is 2.718 up to 3 significant decimal or 4 significant figure. Okay, so this is what is called natural logarithm. Only difference is that in this case we always use the base as E than in the another logarithm where the bases are of different numbers. I will now discuss about some of the examples. So before discussing this list of example, let's see the graph of y equals to ln x. Graph of y equals to ln x. And also if you convert that into the exponential form, so in the exponential form it's going to be like ln x, and you know that there is e actually, so this is actually log of x to base e. So after you express that in exponential form is going to be e to the power y equals to x, and that is x equals to e to the power y. Now in this case, let's interchange x and y only for this here. So if you interchange x and y, your function will be like this: so y equals to e to the power x. Okay, now we are interested to draw the graph of y equal to x and also the graph of y equals to ln x. Let's see how the graph goes for these two functions. So we shall make a graph, shall get ready our graph. This is y-axis and this is x-axis. The one function is ln x, that is in fact log base ex, and your another function is y equals to ex, and the icon ex you can find in your calculator, where you can put shift to the ln function, then you will have the value, you will have the facility to calculate value of ex. Now what I will do, I will mark here 0 now. So if I am talking of y equals to, at the time I am talking of this, y equals to e to the power x. So this is the number. Earlier you have seen that its value is between 2 and 3. So this number is greater than 1, and this is a number in fact, although this is irrational. So when you put x equals to 0, y is going to be, if you put x equal to 0, y is going to be 1. So you will have 1 point as 0, x is 0 on y-axis, and that is going to be 1. Okay, and as this number is greater than 1, so if you keep on increasing this value of x, your y value will rise, and your graph, you can see your curve will go like this towards positive x-axis and to the rise towards the positive y-axis as well, as you increase the value of x towards positive x. Similarly, if you put the value of x less than 0, that is you are going to put -1, -2, -3, then your curve will go like this. It tries to reach near and near to x-axis from negative side, and it will not cross the y-axis. That means it is going to cross the y-axis in negative infinity only. Okay, so your curve will be like this this is the curve for y equals to ex. This is the curve for y equals to ex. And now you can also try the curve for y equals to ln x. So base e, use the calculator in the base e, and the calculator you can see that there is ln, and then you can use that icon on your calculator. So in general, if I am using my calculator, so on the x-axis, your y value is always going to be 0. So when your y value is 0, in that case, if you calculate the value of x, that is going to be 1. And also, if you put ln 1, your value is going to be 0. That means in that way also you can mark this point over, find this point over on the x-axis. Now in this case also, for this function, if you keep on increasing the value of x, you see that your curve will rise up and towards the positive x direction, but this rising will be slow. Similarly, if you put the value of x less than 1 but should be greater than 0. What happens when you reach to 0? Just earlier you have seen that when you put 0 in your calculator for the log, that will give you the syntax error, that is undefined, that goes towards the infinity. We said that that goes towards the infinity. As you decrease the value of x from 1 before you reach to the 0, then your curve will run like this towards negative infinity of y value. So this is the graph for ln x, that is y equals to ln x. Now let's consider one line passing through origin, and you know that its equation is going to be y equal to x. So what can you think about these two functions? One as ln x and another as ex. In this case also, you can see that the function y equal to ex and y equals to ln x are inverse to each other, and therefore you can write y equals to ex both ways implies that y equals to ln x. So that means they are inverse to each other. So property is not that different if you are using the base e. Only the difference is that in natural logarithm you are always using the base e, and for the other logarithm you have any base. So there is no difference in writing the formula or any sort of calculation method or whatever. Only you have to keep the base as e, and in that case we can say that this is the natural logarithm. This is called natural. In short, you can say this is the natural log. Now you might again be interested in looking for examples that relates the natural log. So I am going to discuss some of the examples so that it will be even easy to understand about the natural logarithm. Alright, so let me check one example. Let me take one example. So I am taking one example as I will say 1. So in this case, one example I am taking is solve. Okay, so this is in the exponential form, and we are definitely going to form natural log. So in that case, if you convert into log, what is happening? Here x is called, I will say again in the way I define the logarithm. So x is called logarithm of 18 to base e. Until I get used to of this, I will keep on reading the definition, and then while reading the definition, I will write the function in terms of log. But once I become used to of this, I don't need to read out everything. So we can directly write here as ex equals to 18. Your x value is going to be ln of 18. That means e to the power 18. In order to find ln of 18, what I do in my calculator, you might not be able to see it on your screen, but you should know how to use calculator for this function. I can see here I want ln of 18. I can see the icon ln 18, and this is going to be equals to 2.8 9 up to 3 significant figure. Here also I would like to remind you that, let's see here, you are going to find ln of 18 which is greater than 1. So when the number is greater than 1, the answer is always positive, that we have seen earlier. And then for the sake of your own practice, take 18 as 0.18 so that it will be less than 1, and try that log value in your calculator and check whether this is negative or positive. Now let me discuss one more example. So lastly I will discuss one more example here. So another example I am taking it as example 2, and in that example I am again going to solve. It's going to be 5x e to the power 5x minus 2 is less or equals to 35. So this is an exponential inequality. So how we do this actually? In this case, for a while you suppose this is the equal sign. So if you treat like this, in that case what happens? Here 5x minus 2 less or equals to sign. So 5x here 5x minus 2 is log of this number 35 to base e, and the sign remains as it is. Or you can directly also write 5x minus 2 is less or equals to, instead of writing base e, you can write ln 35. Okay, but at this time, if that will be equality, there will be no risk of writing whether this is less than, or if it is greater than, you can write greater than. But what happens, as we have discussed earlier, that if this number is less than 1, the value of ln of that number is going to be negative. In that case, you have to take care of whether we remain with the same sign or will change it to greater than. Alright, so at this time we don't have risk because this number 35 is greater than 1. So we are definitely going to get the positive value for this logarithm. And after that, I'll use the calculator again. So first of all, let's write here 5x minus 2 is less or equals to, and this value is going to be ln of 35 in the calculator, and my answer is 3.56 if I express up to 3 significant figures. So this is the usual way that we express decimal thing up to 3 significant figure, or sometimes 4 significant figure, or sometimes 3 significant decimal. So these are the usual process, and usually this is stated in your question. Right. So this is now simple inequality that we can solve it to get the value of x. In that case, it is 5x is less or equals to, if you add 2, it is going to be 5.56. 2 plus 3 is 5, and 5.56. If I have calculated this value correctly in the calculator, you can also check it whether or not my calculation is correct. And therefore you can write x is less or equals to 5.56, and that is going to be divided by 5, and therefore your x value is less or equal to 5 ones are 5, 5 ones are 5, so 1.11. Let's check in the calculator. So in the calculator, if I put 5.56 divided by, it was 5, yes, divided by 5, that is going to be 1.112. Or also you can write in the ST mode if it is written, and then you can also write like 139 over 125. So this is how we apply the concept of logarithm and the exponential functions to solve different kind of functions that relates equality as well as inequality. Okay, now we'll move forward to the laws of logarithm. Okay, we shall now discuss the law of logarithm. So you can see that this is the law of logarithm. So the law of logarithm, so this is the log of base a, and for the product of numbers x and y, and it is found that log of x to base a plus log of y to base a again. So this is one of the law of logarithm, and this is good to understand the proof of how left side equals to right side. So in this case, you can suppose for the proof, you can suppose that let log ax equals to m and log base ay equals to n. Okay, so we have supposed that log base ax is m and log base ay is n. Now, by using the conversion way of log to exponential function, so we shall convert that into the exponential function one by one. So here, if you convert this logarithm function in terms of exponential function, and in that case your x is going to be here a to the power m, and then here y is going to be a to the power n. Now as you see, we are dealing with the product rule, so we shall take the multiplication of x and y. So therefore we have now x times y equals to, x means a to the power m, and times y means y means a to the power n, or you'll get that x y is equals to, as the bases are same, the power gets added, so power gets added. So when you add them, so it is m plus n. Now in this case, you can apply the definition of logarithm. You suppose that this is one number, this is another number, and this is in the exponential form now. So in that case, by definition of logarithm, we have m plus n. So here m plus n is the logarithm of number xy to base a. That is, we have log base a xy is equals to m plus n. Therefore log a xy equals to, m means you can see here, m means where is it? Yes, here m we have supposed for log x, so we shall write log x to base a in place of m, and in place of n you can write log y to base a, and in this way it is proved. Now if you'd like to see some examples here, so for example, I'm taking example number 1, and for the example number 1, suppose this is log 13 and the number is 2 times of x, then that is going to be equals to, if you use the law of logarithm in 1, then you'll have, you can expand it like this. So in this case you can expand it like this, means it is log x and it is like log y, and in that case you can write log base 13 of 2 plus log base 13 for x. So in this way you can simplify the logarithm function. And I can tell you another example also. So let's take another example, like for example, you can take any base c, so log base c of any number. For example, it is x squared times y times t squared, for example. And if you use the first property of the logarithm, so it is log x times y is x log x plus log y. If there will be another number also, for example z, in that case it will be log x plus log y plus log z. So here we have the three numbers in this case, and if you are going to apply the first law of logarithm, which is for the product form of the number, so here are the three numbers in the product form. So when you expand it, it will be like this. It will be like log c x square for into plus log base c y plus plus for this into, and then it is log base c for t square. So you can see that in your problem area we are going to apply in the same way that we have been doing here in the example. Now we shall discuss about another law of logarithm. So another law of logarithm is that one time we have multiplied, then this time we are going to divide by. So the second law is that log to the any base of x divided by y, or you can say that is log to any base a x divided by y is going to be equals to log x to base a minus log y to base a. Okay, so this is the another property of logarithm. In this case we have divided one number by another number. When we expanded, our formula is like this. And now we shall see for the proof of this formula. So in the proof for this formula, if you look back to here we have supposed log x equal to m and log y equals to n for the base a. And after converting this logarithm into the exponential functions, we have the terms like this. So here, in order to find the product rule of the logarithm, we have multiplied these two numbers x and y, but at this time we are dividing the number. So therefore we take the division of x and y, so that first we start with x divided by y. So when you write x divided by y, so x is a to the power m, you can see here, and y is a to the power n. So I will write here, this is a to the power m, this is a to the power m, and this is a to the power n, and here it is, because bases are same in the numerator as well as in the denominator, so a to the power is going to be m minus n algebraically. Now here also you can apply the definition of logarithm, where you suppose m minus 1 as one number and x divided by y as another single number. In that case, by definition of the logarithm, you can say that m minus n is the logarithm of x divided y to the base a in this case. So while finding the product rule, we multiply the exponential functions x and y, and for the division of the number we divide the exponential functions x and y here, and that is we have now log base a x by y equals to m minus n, and you have m as, you can see again here, m as log x to base a, so that is log x to base a minus n as log y to base a, n equals to, so it is going to be log y to base a, and hence this is proved. Now we can deal with some example here. So I'm taking example 1 as, let's say you have log of base 3 for 1 divided by 3 in this case. So suppose that the numerator is x and denominator is 3 for any base 3 here. So if you use the quotient rule for the logarithm, you can expand this sort of thing in this way. Just to apply that formula, so it is going to be log of 1 base 3 minus log of number 3 to the base 3. So fortunately in this case we are able to calculate this sort of log values without using the calculator. So in this case you can see here that log of any base for 1 is always 0, and if the number and the bases are the same, we know that this value is going to be 1. So finally you have the value of this log is -1. So this is one of the example. If you'd like to see another example, so let's take another example as log to any base b. For example, suppose that x y by u, for example. Then how do you expand it? Just you use here, you can use both the formula, the product rule and the quotient rule for the logarithm. So first of all, because we are dealing with the division thing here, therefore we use the quotient rule. So in the quotient rule, it is log x minus y. So here log, in place of x we have got y and base is b here, and then because of this division, this is minus, then log of u and the base is again b. Now here you can see there is another step where we can expand the log to the base b for xy. So here if you use the product rule, it's going to be log base b x and plus log base b y, and we already have here minus log base b u. So in this way we can apply those law of logarithm to the problem area as well. So here this is only for the examples, and same sort of concept we are going to apply when we go to solve the problem. We can look for another law. That law is called the third law. We name it as third law, and that law is called power rule. You can say that is power rule. Power rule means in the power rule you can see here log to base a, and there is one number, suppose that is power is m. Then what happens? The power will be in front, and then it will be log x to base a. So this is another relation between this kind of logarithm. So where you can see here the base is a, it can be anything, maybe c, d, 19, 11, whatever, it can be anything, but at this time there is power m to this number x. This can be in terms of either constant or variable. So m can also be either constant or variable. So in this case it is good to know how to prove it. So proof for this is like this. So if you prove it, you can just take like let log base a of x equals to n. If you convert that to the exponential form, it's going to be x equals to a to the power n. Now taking power m to the both sides, so I'm taking power m to the both sides here. Why m to the both sides? While proving this, we have to always think about the relation given. So what kind of relations are given there? Accordingly, we have to think in order to get to the result. Okay, now we shall go ahead in the step. Now after this step, it's going to be x to the power m, and it's going to be a to the power n times of m. Okay, now suppose this is nm as a single number, and this x to the power m is also as a single number. Okay, and now you can apply the definition of, by definition of logarithm, we have here n times m is equals to, so n times m is called logarithm of x to the power m and to the base a. that is we can write logarithm of x to the power m base a equals to m times of n, equals to m times of what is n then? N we have just supposed here that log ax. So n is in fact log ax. So in place of n we can write log x and the base is a. So therefore it is proved. Now if you would like to see the example, we can work like this. So I will say this is example 1, and in example 1 you can take it like I'm taking the log. So in that case let's see how it can be evaluated. So this is log base 3, and you know this 9 can be factorized to the power of 3 to 2. So 3 square. So in place of 9 you can write 3 square. Now you can see, if you compare this result with this result, you can see that 3 is in place of x and 2 is in place of m. Then what happens then? The power will be in front of this logarithm, and we are left with here only log 3 to the base 3. Now you also know that here the bases are same, therefore log value is going to be 1. So therefore you can write here 2 times of this value is 1. So 2 times 1 is going to be 2. So answer of this logarithm is 2. That is we have evaluated this logarithm and its value is 2 now. You might be interested in looking for another example as well. So just consider the example like this, and here I will write a bit extended form of this product as well as the division of the numbers. So here take log to any base n, and it's going to be x cube times y divided by z. Now let's think. Can you think of it? You have until now the knowledge of 3 laws of logarithm. One as product rule, another as quotient rule, and now this is the power rule. And here you can see you can apply all those rules. So we shall apply the rules one by one. So here log base n, and you can see here x cube y. So we can write x cube y, and for division we can write minus by using the quotient rule of the logarithm. And here log base n, and this is z. So because of the division sign, okay, and we have seen in the law of logarithm in the division form of the numbers. So if this is divided by, here we put negative sign. Now here inside you can see this is x cube and y are multiplied together now. So you use here the product rule. So if you apply here product rule to this bracket for the logarithm to the base n, in that case you will have the expanded form of the logarithm as log to the base n, and this is x cube. In place of into we write plus, and then log y, and the base is n in this case, and we have already this term going on, so it is log z. Now in this case you can apply the power rule. When you apply the power rule, it comes in front of here, and then it is log to the base n x plus log y base n minus log base n of z. Okay, so in this way we apply this power rule, product rule, and quotient rule for the logarithm to the problem area. We now have a few more laws to go there. You can see that logarithm property 4, or you can say the rule 4. So I'm not writing what is that rule. You can say that is the reciprocal rule. How to make reciprocal of logarithm function. You might be interested in another kind of law of logarithm. Say it is base a and b, and that is going to be equals to 1 by log of base b and for the number a. Now just have a look at this equation. So log base a b, when it has been made reciprocal, then what happens? The base and the number positions have interchanged. So this is also one of the law of logarithm, and that may be termed as reciprocal law of logarithm. So if you are interested to prove it, you can do so also. So in order to see the proof, you can suppose any of these that number. So I'm supposing the first as let log base a of number b is equals to n, and if you convert that into the exponential form, it's going to be b equals to a to the power n. Now at this point I'm taking log to base b to both sides. In that case it's going to be like this. So b equals to a to the power n, and according to how we mentioned here, you have to put log base b, and here also log base b. That's all right. Now if you move forward to this step, you can see that the given number have the same base, so value of this sort of log is 1, and here if you apply the power rule, your n will be here, and you have log base b a is here. So in that case what you can see is actually n is going to be 1 divided by log of a to base b, and n you have already supposed as for log a for the number b. So in place of n you can write, therefore it's going to be log base a for b is going to be 1 by log base b for number a, and this is proved. Now if you would like to see the example based on this law, so in that case in the example you can see the example is log 15 and this is going to be 13. So when you need in your problem area, you can write log 15 into 13, and then you can write like 1 by log, just interchange the base and the numbers, is going to be 15 and that is going to be 13. So in this way you can apply that to the problem area as well. You can see for another property also, you say that this is one of the law. So this is in fact log of any number, say b to base a, and it is found that if you introduce any number c in between b and a, you can write at the base c of b and times log base b and c. So another property of the logarithm is like that. So you can insert a lot of numbers between b and c, and if you can keep on making chain of such kind of logarithm, then that will be true. And there is another law also that you can see here, like log a base a for b is going to be equals to log, it is b, so you can write here b, and if there is any number introduced here it is c, and then down to that it is a, so we write log of a and with the number c. So if you consider at this point, so this result can be followed from the law 5, because since here log, this is c, sorry, it should be a, so that this is b, c, c and a. So if you use the property 4, and then in that property you have seen that log b by a is equals to 1 by log ab. So here this will be going to be, this is log C A, this will be going to be, when you make it reciprocal, it will be the base and the number position will be changed, so it is A and C, and hence if you use this property over here, then you will have the result 6. Okay, now let's summarize number E, which is less than 3 and is greater than 2. So in this case, you know that log of base E is denoted by ln, and this is called the natural logarithm. So in place of writing log of other bases, when we take log of base E, that is going to be natural logarithm, and we can express the laws of logarithm in ln form as well. So first I am taking ln of xy, and then it can be written as ln x plus ln y. Similarly, ln x divide y can be written as ln of x minus ln of y. Thirdly, ln of x to the power m, for example, so it can be written as m times of ln of x. So in this way we can define the law of logarithm in the natural logarithm form also. So in this way we can summarize this law, and other laws can also be summarized like this, where the base is E. Now we shall discuss some examples that how we apply the logarithm to the problem area. So in that case, I have some example here. So first of all, let's take one example. It states that, so in this case we will apply all the properties of logarithm to evaluate this kind of log function. So here you can see, you start from here, so it is log a because we are going to evaluate it, and this is y, and it is cube root of x, so we can write x to the power 1 by 3. Now you apply the quotient rule, then you will have log a y minus, because of this division, and then log base a of x to the power 1 by 3. If you go to the further step here, so log base a y minus, as this is the power of x, it will be here in front, and then it is times log base a x. Now you can see here log base a y is given as 4, so you can write here 4. This is 1 by 3 times log base a for x is given as 7, so you can write 7 at this place, and now it is 4 minus 7 by 3, so it is 12 minus 7 by 3, and that is going to be 5 by 3. So in this way we can evaluate the logarithm, provided we have knowledge of all the properties of logarithm. You might be interested in another kind of example also, that how we can do this. As for example, I am taking another one example also that will clear how we use the properties of logarithm to the problem area. So in this case, this example says that solve. So this can also be done by using our usual way of solving the simultaneous equations, but here on one additional knowledge that is required is the law of logarithm. So here you have got two equations. So one equation you can say xy equals to 81, this is equation 1, and another equation is log to base x for y is going to be equals to 3, and that is the second equation. So now I am taking log to base x to both sides of equation 1, then you can write like this. This is xy equals to 81. So at this point we are going to take log to base x here and log to base x here as well. So when I applied this, then what I have at this point actually, if I go to the further step, so here it is xy, that means it is x times y. Then if you apply the product rule for logarithm, it's going to be log x to base x plus log y to base x. And if you are interested, you can just leave it like this, or you can factorize 81. If you factorize 81 in terms of 3, it's going to be 3 to the power 4. And then you see that here in this logarithm, the number and the bases are the same, so its value is going to be 1. Plus you have log of y to base x is 3 from equation 2, so we write here 3, and it is 4 will be in front of here when you apply the power rule to this term. So then it is going to be 4 times of log base x, and this is 3. So you can see in this case 1 plus 3 is going to be 4, so 4 and 4 both sides have been cancelled out, so you are left with log of number 3 to base x is 1. And when you convert that into the exponential form, yes, it's going to be like 3 is equals to x to the power 1. So therefore when you convert that into exponential form, it's going to be x to the power 1 equals to 3, that is x equals to 3. So we have got one of the values from x and y variables. Now we'll see for the value of y. So put x equal to 3 in equation 1, or either in 1 or 2. So I'm putting it this time in equation 1 in order to get the value of y. So from equation 1, x value is 3, so I write here 3, then y, and this is 81, and therefore our y is going to be 81 divided by 3, and when you divide 81 by 3, it's going to be 27. Therefore value of x is 3 and the value of y is 27, and this is our answer. Okay, that is all for now. Hope you found this class helpful in understanding exponential and logarithm functions and how to deal with the problems related to this topic. Okay, that is all for now, and thanks for your patience.